Hi, everybody. Welcome. Thank you for coming to this webinar today. My name is Haley, and I work with the Columbia Mountains Institute of Applied Ecology, that is CMI for short. And I join you today from Revelstoke, BC for the fourth talk in our fifth season of the CRED Talks. These are the Columbia Region Ecological Discussions. And today we'll be hearing from Greg Utzig, who will share some insights in a talk titled Climate Change and the Biodiversity Crisis. Thanks for taking the time to join us today. We really do know and recognize that everyone is juggling a lot in life right now, so we appreciate your presence online today. Before we get started, and while we continue to have people log on to this webinar, I'd like to take the opportunity to tell you a little bit about CMI, for those of you who aren't familiar. And for those who are familiar and have been watching the CRED Talks, I apologize, as you've probably heard this spiel many times now. So CMI is a nonprofit society and an association for people working in the various fields of ecology. Our home range is southern British Columbia, Canada, but increasingly we're seeing membership from across BC into Alberta, the Yukon, and up into the Northwest Territories. One of the main things that we do is provide professional development opportunities, such as conferences and courses. And some examples from the last few years include a recent workshop on forest fungi and their role in the ecosystem, a foundation level course, Understanding Statistics and Decision Making for Resource Managers, advanced field ornithology courses, a variety of plant identification courses, critical habitat screening workshops, statistical methods courses, and a diversity of conferences exploring complex topics like the ecology of regulated rivers, incidental take of migratory birds, and assessment of camera trap surveys for wildlife conservation. Our website is the best place to learn about the sorts of things we do, and it contains great resources such as proceeding documents from all of our major events. You can find those at cmiae.org. All right, so for this particular project, the CRED Talks, this is the first year that we've moved the speaker series to a webinar format. So thank you, COVID, for that. One thing to thank COVID for, and welcome to everyone who's here as a result of this event going online. It's been really fun to see who signs up for these webinars. So with this in mind, I'd like to ask that everyone tell us who you are and where you're from. To do that, let's use the chat feature. So those of you who are not familiar with Zoom, if you take your mouse down to the bottom of your screen and hover there, you'll see a mouse pop up on the control panel. And this is where you can include your name, where you're from, include the country if you can, and your affiliation. And I can see, oh, I've got a couple comments here, and maybe I'm gonna have to continue with this introduction and then I'll deal with some of those comments above. Thanks. So I just wanna say that it's typical for our events who have a great mix of people, mix of academics, students, environmental consultants, industry representatives, teachers of various descriptions, and government resource managers. At this time, I'd like to let's just pause for a moment to see that these comments are coming in. Yeah, there's lots. Great, thanks everybody. Creston, Laura, Marcy, hi Marcy, Danny Thompson, hi. Okay, great. Thanks, everyone. Okay, so we're up to 54 people now. Okay, so right now I'd like to thank the Columbia Basin Trust for your financial support of this series. Without this support and the donations provided by many of you today, this project would not be possible. So thank you very much, and especially thank you to those of you who had a chance to donate. Before we get into the nitty-gritties of this webinar, I'd also like to acknowledge and honor the 4 nations on whose traditional territory I'm broadcasting from today in Revelstoke, BC. And that is the Sinixt, the Kootenai, the Sequapum, and the Silk. Okay, so now for some of those nitty-gritty details. This webinar is being recorded and it will be posted to our website later today. For the best experience, I recommend that you select Speaker View. All attendees have been muted for the session, so the best way to communicate with the panelists and each other will be through the chat feature, as many of you have figured out already. We're going to have time for questions at the end. To pose a question, simply type that into the chat. We may not have time for all the questions, but we will do our best. All right, and now time for me to introduce Greg, who you're all here to listen to. So Greg Utzig is a conservation ecologist and land use planning consultant with over 40 years of experience in environmental impact assessment, terrain and vegetation mapping, watershed analysis, habitat inventory modeling, a wide range of activities related to forest management and biodiversity protection. At present, his focus is on adapting biodiversity conservation measures to the reality of rapid climate change. He's worked with a variety of clients, including government agencies, non-governmental organizations, First Nations, and the forest industry, both in British Columbia and in South Africa. Greg has a master's in science and maintains his designation as a professional agrologist. He studied with the universities of Wisconsin and British Columbia in geology and forest soils. Whenever he can avoid his computer, he spends time on Kootenay Lake or in the surrounding mountains. Some of his work on climate change and conservation can be found at www.kootenayresilience.org. And I'm sure he'll share those resources with you. So with that, Greg, I pass it to you. Thanks for your patience, everyone.
There we go. Okay, thank you very much, Haley. I guess I'm going to start off by just saying a few things about the talk today. This is not the usual talk I give about climate change. I've been giving a number throughout the region, and I usually try and focus on local issues and local impacts of climate change. In this particular talk, I'd like to step back and look at kind of the global context. And I think it's trying to avoid that proverbial phrase of not seeing the forest for the trees. This time we're going to step back and look at the forest. And I guess I would say that what I'm trying to do is to say that climate change is a big issue. And it's not just something that we can resolve individually. It's going to take a concerted, consolidated effort to do this on a global scale. And secondly, the implications are global, and I would argue potentially existential. And with that, I'll begin. And I guess what I want to say is right now we're really concentrating on the pandemic, but I would argue that's just merely a small sideshow to climate change. And I think that the biodiversity crisis is part of the same very large issue. So we'll begin with that. I'll start with that and then move into climate disruption and then talk about why I think it's an existential threat. Why is this happening? And I think this feeds into both climate change and the biodiversity crisis, is what's been deemed the great acceleration. And you'll notice that almost all this information has a reference at the bottom of the slide. And most of the material I'm presenting is from peer-reviewed articles. I'm trying to stick to the science. Unfortunately, there's a few things that are government reports and some that are independent consultant reports, but probably 80% of what I'm presenting is out of the peer-reviewed literature. And this particular one here, we're looking at what is happening over the previous few decades, and the line is 1950, which is generally looked at right now as potentially the beginning of the Anthropocene, the new geologic epoch that's been proposed. And as you can see, things dramatically change around the 1950s. But this also feeds into Earth system trends. Changes in carbon dioxide, which I'm sure you've heard of, methane, surface temperature, ozone. A huge amount of things are changing because of what we are doing to the Earth. Another way to look at this, which I'm sure most of you are familiar with, this concept of the ecological footprint. This was some work put together by WWF, which shows that the dashed line running across the center is basically the Earth's capacity to provide these services to humanity. And as you can see, since the 1980s, we've started to creep up over the top of that capacity. And today we're well beyond the capacity to supply our needs. I might just say that carbon seems like a funny one to put in terms of footprint, but basically the way they've done that is to look at how much forest land it takes to sequester the carbon we're putting into the atmosphere. Now, what does this mean for biodiversity? Well, the most recent one I can find that looks at biodiversity in general for British Columbia was done back in 2008, the status of biodiversity in BC, looked at various human activities, the stresses that places on ecosystems, what elements of biodiversity affected, and what are the overall impacts. The result of that was identifying 4 biogeoclimatic units that are considered to be of conservation concern, certainly the drier ones, partly because of our control of fire, and secondly, because of development, because they're mainly low elevation subzones. And they come up with a total of over 1,000 species of provincial concern, and this is back in 2008. More recently, we've had a report by Price et al., which looks at old growth and its risk. And you can see that the moderate and high production sites in British Columbia, about 80 to 90% of them are at a high risk. In other words, they have less than 30% of the natural amount of old growth that would be expected to occur in those sites. We've had an old growth report from the province, which is actually pretty good, but the province's reaction has not been good. Basically, they didn't take the high road and do the high priority recommendations. And lastly, we can talk about some specifics here in the Kootenays. We've lost 2 caribou herds, and there's a whole bunch more that are in that high risk category. So these things are happening locally. If we look at it on a continental basis, this is just an example of looking at bird populations. And you notice the graph on the left, that's as it changes in billions of birds. And you can see that we're down to almost 3 billion birds between 1970 and today. And we can look at that in terms of different habitat types. Grasslands are the hardest hit because we've converted most of our grasslands to agricultural land. But even the Western forest, which dominates British Columbia, we're looking at being down about 30% since 1970. So there's pretty substantial losses in birds. And if you look at migrating birds, this is radar surveys that were done between 2007 and 2017. You can see the eastern half of the continent is in great decline, the Mississippi flyway as well as the Atlantic flyway. Now, to touch on something that should piss off a few people, nobody ever wants to talk about this, but one of the major contributors to that are domestic cats. This was a very interesting study which looked at radio-collared domestic cats and to find 925 of them in 6 different countries. So it's a pretty good representative sample. They were killing 3.5, on average 3.5 prey per month. And that adds up to almost 40 per year in some cases, certainly higher, slightly higher or equal to an average natural predator. And feral cats were even expected to be worse. So we need to, if we want to resolve the biodiversity crisis, we need to look at everything. Also, there's some other studies that have come out recently looking at changes in habitat for species across the world. And as you can see on this graph across the bottom, we're talking about the increase in agriculture and urban area in millions of hectares. And then on the left is the average decrease in habitat size. And this was based on habitats for 16,900 different species from 1700 to today. And as you can see, we're down about 18%. So a fairly substantial loss. And this can be broken down by how much loss and what kinds of species are affected. You can see on the right, we're looking at substantial losses. The dark colored bar on the right of the triplet is more than a 50% range loss for those species. And this, as you can see, the trend, it's ever increasing. Global extinction risk from 2019 report. from the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. That's a mouthful, the IPBES. We're looking at anywhere from 10 to 40% percentages of species globally that are threatened. They're either vulnerable, endangered, or critically endangered. So what are we doing about this? Where are we at? Well, the major step to try and change this trend was back in 1992 at the Rio Earth Summit in Brazil, if I remember, in Rio. The government of British Columbia actually sent a delegation to that. I was very envious. Unfortunately, I was not in the government at the time. And there were some great promises made at that. But as you can see, here we are 8 years later at COP6. This is the UN Convention, the Conferences of Parties who had signed the convention. In 2000, things had still continued to deteriorate, but they made a promise to achieve by 2010 a significant reduction. Unfortunately, we came to 2010 and things were still worse. And then they made another promise that they set up the Utzig targets, which are 20 different biodiversity targets that were going to save things in the next 10 years. And in 2019, we had an assessment report that just came out a couple months ago. And as you can see, most of the responses to those 20 targets are in the poor category, with only a half a dozen that are in good. So again, we failed. Now this year, there was supposed to be COP26, where we're going to renew and again make promises, but this has been postponed for a year because of COVID. And we're unsure where we're going to go from here. The report, which did the assessment in 2019, modeled various projections. Basically, the trend doesn't look good, but there's still hope. If we look actually at extinctions themselves, the lower dotted line is a background level of extinctions that would normally occur under natural conditions. And what these, and that's based on calculations from the fossil records. What we're looking at here are graphs of actual extinctions. And as you can see, they're substantially above the background level since the Industrial Revolution, basically. And this was a very, very conservative estimate. A less conservative estimate actually doubles those numbers. And you can see some are better known than others. Birds don't change, whereas mammals increase and other species change. And what this graph on the bottom shows is that if those groups of species were going extinct at the natural level, how long it would take to match the level of extinctions that are occurring today. So for fish, instead of it occurring in the last 20 or 30 years, it would have taken somewhere between 2,000 and 6,000 years to have the same level of extinction. And as you can see for amphibians, there's a lot of uncertainty, but anywhere from 2,000 to 10,000. Birds seem to be better known. The uncertainty is a bit narrower. But in any case, you can see we've speeded up the extinction rate substantially. So this isn't the first time extinction has occurred. There's been 5 mass extinctions in the history of the Earth that are recognized, and in numerous smaller ones. I think the first one, the end of the Ordovician, I think a lot of people are probably familiar with the Burgess Shale and the incredible diversity was there. It was wiped out by that first mass extinction at the end of the Ordovician. And then there were 4 more ones subsequent to that. The last one, the end of the Cretaceous, is the one most people are familiar with. It's the one that wiped out the dinosaurs. And one of the more interesting facts about these is that they were all related to climate change events that occurred in the geologic past. The only main difference is the one at the end of the Cretaceous, as well as climate change. Climate change had begun the extinction, and then the meteorite in the Yucatan finished it off. Which leads to the next part of my discussion, which is climate change itself. So where are we at? Well, this is a record of carbon in the atmosphere over the last 800,000 years based on ice cores in Antarctica. As you can see, it occasionally went almost up to 300 parts per million, but generally was ranging between 185 and 275. And where are we at today? Well, we're up at 418 in June. It's a bit lower right now because during the summer in the northern hemisphere, it usually drops because of the uptake by forest vegetation. But that is the record, and every year it's going up by 2 or 3 parts per million. So we're now embarking on a huge experiment at the global level, unprecedented for 800,000 years. And as I get further into this, you see it may be for 20 million years. Where does all this CO2 that we're emitting go? Well, about 2/3 of it ends up in the atmosphere, which brings us to that 418. And the other third of it is split up between being absorbed from the ocean or being taken up by forests and vegetation ecosystems. I could talk a lot about the ocean. That uptake by the ocean is great for the atmosphere, and it means we're not heating up as fast as we could, but it has incredibly bad impacts on the ocean, but we don't have time today to delve into that. And it's generally a feeling that climate change is something that's off in the distant future. And yeah, we'll do something about it eventually. But if you look at this, each of these stripes indicates 1 year's temperature. And the coldest year is about 1.35 degrees centigrade colder than the hottest year. And you'll notice that the last 10 or 15 years are the only ones that go into the red. It's not something that's going to happen in the future. It's already happening. We just haven't noticed. Well, some people have noticed. Bringing it back locally, this is what's projected for the Columbia Basin by the 2050s. So in another 3 decades, we're looking at, in the southern part of the basin, increases in temperature of 3 or 4 degrees and 1 or 2 degrees, well, during the summer, and then 1 or 2 degrees, maybe 3 degrees in the winter, spring, and fall. And in terms of precipitation, we're looking at increases in precipitation in 3 seasons and decreases in the summer. And I think one needs to look at that and think about what are the implications. Well, number one is increased drought, because we're going to have a lot more evaporation and a lot less precipitation in the summer, but it also obviously means increased fire and likely substantial stress on our ecosystems. Some previous work I did looked at what kind of changes might we expect. And I don't have time to go through the details of how this was done, but basically these projections were based on various models and scenarios that were run off the global climate models for British Columbia. And with the help of scientists at PKIC, we picked 3 different scenarios. And what we tried to do was to outline the range of variability, because we don't know which of these 40 different scenarios are correct. So we thought it was best to outline the edge, and that way we would know the answer is likely to be somewhere in between these 3. So if we look, the model basically takes the climate projected on a 1 kilometer grid and projects it into the future, and then looks all over Western North America for where that climate exists today and says what kind of ecosystems are at that spot today. And that's the kind of ecosystem that potentially could exist in that climate in the future. And as you can see, this one is one that has a moderate increase in temperature and a moderate increase in precipitation, the axes on the graph there. But you'll notice there's an incredible increase in grassland and steppe environments in the lower elevations. And the Engelmann spruce of alpine fir, the purple on the current map, pretty much disappears. The upper elevations become similar to lots of different types of hemlock, interior cedar hemlock, and the upper elevations tend to go toward coastal type of ecosystems. If we look at the hot, wet one, we get a lot more coastal looking ecosystems and a bit less grasslands, but still a significant increase in grassland habitats, grassland climates that would support grassland type habitats. And lastly, if we get the very hot, dry one, we get, as would be expected, a huge increase in the potential for grassland steppe environments, and the upper elevations become mainly interior cedar hemlock types. And this is basically for 6 decades from now. We looked out that far because we were mainly wanting to look at what it meant for forests. And of course, if you grow trees, you've got 5-6 decades minimum. I think the important thing is just to say, yeah, these are different. So there's a fair bit of uncertainty, but I think there's 2 things that all 3 of them say. One is the lower elevations are going to be significantly hotter and drier. And number 2, the upper elevations, the Engelmann spruce subalpine fir environment that we and many species depend on will likely disappear. But exactly what it'll become, we don't know. There's also extreme climatic events. This is for Canada in general. We're looking at 50-year events going down to occurring almost every year by the end of the century. Precipitation events, we're going from 50-year events down, them becoming 10 to 20-year events, even as low as 5-year events. Lots of other extreme events. 48 degrees for a temperature in Australia last winter. Central America had 2 hurricanes in 2 weeks. One of those went from a tropical storm to hurricane in a couple of days. Nelson has had experience of 40-degree temperatures. Atmospheric rivers are becoming more common. And this is a number of billion-dollar disasters by category in the US. As you can see, they're increasing substantially. There's also health implications, heat waves, pollution, emergency evacuations. These are so drastic that last year, the Canadian Medical Association, Physicians for the Environment, and Nurses Association all came together to call on the government to do something about it. But not much is happening. In fact, even globally, not much is happening. When we look at the amount of emissions that are coming out today, we're up to 55.3, and this includes CO2 and other greenhouse gases, such as methane and nitrous oxide. As you can see, we need substantial reductions if we want to bring ourselves down to that 1.5 or 2 degree range. The unconditional and the conditional are what's promised under the Paris Accord. So there's a huge gap in terms of what we need to be doing. And this is by 2030. That's 9 years from now. And it's not happening. So do these constitute an existential threat? Do we live up to our name? Some would argue no. Very interesting view of evolution. And lastly, can we turn it around? If you're familiar with resilience theory, there's the idea that ecosystems basically occupy one of these little basins, and they vary within the basin, and occasionally under incredible stress, they'll hop into the next basin. Unfortunately, climate change ends up looking more like that lower diagram where we just keep moving downhill because climate change keeps getting worse and worse. The same concept can be applied or has been applied to the Earth, given that during the Holocene, we've basically been in a basin somewhere between glacial on the left and interglacial on the right. And with human emissions, we've pushed ourselves into this warm, very warm interglacial. And if we continue on with the biosphere degradation and increase things, we potentially cross a planetary threshold and into a new depth, which has been termed hot house Earth. Alternatively, we can change our ways and go with increased conservation and stewardship, reduce our greenhouse gases, and maybe bring ourselves back to where we were. But the important thing is to look at these intrinsic feedbacks that push us into the bottom. There's lots of biosphere feedbacks. Terrestrial biodiversity loss ends up creating, we get lag species responses for their, and therefore ecosystems degrade. We decrease the CO2 uptake. We end up with permafrost thawing, releasing more carbon dioxide and methane. we can change marine diversity and end up reducing the uptake in the ocean and actually put more carbon into the atmosphere, which again leads to more climate change. Some modeling has shown that for these various different scenarios, we can end up with substantial increases in carbon based on the biodiversity crisis, basically. There's tipping points as well. These have been identified, whereas the Greenland ice sheet completely melts, which then leads to the thermal haline circulation changing. In other words, the Gulf Stream can end up losing Arctic sea ice, and then we lose the albedo, which keeps us cool, and all these other possibilities. A number of these have already started. They're already happening now. And there's a whole bunch that seem to be just starting. The Gulf Stream does seem to be slowing down, but it hasn't been proven beyond a doubt that it's happening. Permafrost is melting, but not enough to release huge amounts of methane yet. Just to give a feel for how these kind of feedbacks work, this is just looking at British Columbia, and this is the amount of CO2 emissions and sequestrations. And it's a bit complicated, but if you look at the green at the bottom, this is the amount of carbon dioxide that's taken out of the atmosphere by ecosystems in British Columbia. The purple above the black line is what's taken away and emitted with forest products and logging. Yellow is slash burning, and the brown is wildfire. And you can see where the mountain pine beetle outbreak happened between 1999 and 2015. The amount of sequestration by the forest reduced dramatically. The green lines get much shorter. And then, as well as that, we had a serious outbreak of fires in 2017 and 2018, and that increased the output from wildfires substantially. So in this particular case, with the red line, we're looking at the net forest emissions in British Columbia. They went from being negative to actually being positive. So our forests are no longer helping us, they're actually making it worse. That's the way these feedbacks work. And how bad could it get? Well, this is looking at the amount of CO2 in the atmosphere for the last 100 million years. And the red line indicates where we're at today, roughly. And the three on the right offer these different emission scenarios. The 2.6, we're already pretty much beyond that already. That means that we reduce emissions to near zero quickly. 4.5 is about the 2-degree one, which we might do, but are unlikely. And 8.5 is if we continue the way we're going. So we could actually end up with so much carbon dioxide or carbon dioxide equivalent in the atmosphere that we exceed anything that happened in the last 100 million years. And that goes all the way back to the mid-Cretaceous. And you can see once you get above about 1,000, Antarctic as well as Northern Hemisphere ice completely disappear. Major changes to the Earth system. And what happens? Well, the Earth will recover, but modeling that was recently completed says that it'll take a few 100,000 years. Based on the geologic record, the Earth does respond. But there are these extinctions in those previous events. And the question is, are we going to create a new one? And what will it mean for us as humans? If you look at the human evolutionary tree, when we eventually get to Homo sapiens, being ourselves, there were numerous other Homo species which have subsequently gone extinct. The last three, actually, a recent paper that came out this month showed that they were a result of climate change. So I guess the existential question becomes, are we going to be the fourth? Some people do get it. Shockingly, not the person I would normally be quoting, but in fact, he certainly gets it. And of course, a young girl, a young woman. So that's it. That's my attempt at raising alarm at a global level. Thanks.
Thanks, Greg. Gosh, it's hard to know what to say, really. I know, like you said, it is a different sort of talk than you normally give. And when I look at the attendance list, I can see a lot of people on here who I'm pretty sure have heard you speak before. So maybe they have some new questions for you that they haven't been able to ask for, that you've sparked some curiosity. So if anybody has any questions right now, put those into the chat. And as they start coming in, what I'll do is I'll relay the questions to Greg, and he'll do his best to answer. And if we want to ask each other questions, we can do that. I know it's not the easiest to chat with one another in this format, but we'll do our best. Are there any questions? And maybe while I'm waiting for those to come in, I'll just, I'm going to note that on the, maybe we just won't do that slide yet, Greg, because I'll identify that talk in a little bit. I'll just let you know that on the back end with me here, I wasn't going to introduce Carrie, but I've decided to, while we're waiting for the questions. I have Carrie Nadeau in the back end with us here. She's the CMI president, and she's just helping in case I need it, some backup here. So Carrie's here as well if you had any CMI specific questions. Carrie, if you just say hi, your little video box should pop up.
Oh, hi, everybody. Great to be here with Greg. See, great turnout.
I think we're all a little bit stunned. No questions at the moment. Oh, here we go. We have one from Marcy. Thanks, Marcy. Greg, can you speak more about the changing role of forests in sequestering CO2?
Yeah, it's you could easily do a whole talk on that. There's a lot of information. I guess in terms of British Columbia itself, the biggest factor is the fact that we've lost huge amounts of forest, first to the mountain pine beetle epidemic, and then subsequently to forest fires. And because of the increasing temperatures and decreasing summer precipitation, the amount we're going to lose of forests in the future is dramatic. And admittedly, forests can recover, but it takes many years for the forests to become large enough that they're actually sequestering as much as the forests that we've lost, the mature forests. It's that same argument about old growth forests. Yes, they're not putting on a lot of productive growth, but they are sequestering carbon. And when we cut them down, it takes a very long time to bring them back to where they were before. There's been quite a bit of work looking at tropical forests and whether they're taking up more carbon or less carbon, which of course they end up being some of the most productive and the best at sequestering carbon. And right now, I think I would safe to say the science is a bit out on that. There was a recent paper that came out last week, actually, that suggested that minor drought in the tropical forests actually increases their sequestration, whereas major drought makes it worse. So exactly whether it's plus or minus, but the fires in the Amazon and the clearing of the Amazon is having a dramatic effect on reducing carbon uptake by forests.
Thanks, Greg. Next question comes from Genevieve. Can soil improvement make a difference? How would we do that?
I guess, first of all, it's really tough to answer that in a general sense because soils are so variable, going from shallow rocky soils to deep moist soils with lots of organic matter in them. I think the main implication in terms of soil and its sequestration of carbon is keeping them shaded so that they, in fact, respiration is reduced and they're able to maintain their carbon. There's various treatments you can do, but in a forestry sense, keeping the forest on the soil is probably the best thing you can do. Agriculturally, there's lots of things that are talking about in terms of sequestering more carbon by not plowing, having no-till agriculture, using biochar, burning vegetation and then burying it in the soil because it stays in the soil for a long time. It's, again, one of those things that's not a simple answer.
Great, well, thanks for attempting the answer anyways. So next question comes from Jenny Fike, who you may know, and she says, the BC Green Party currently has an open policy proposal underway. proposal process underway. Have you considered putting in a proposal to inform the GP policy and climate change with information and better link it to the biodiversity crisis?
No, I haven't. It's a possibility.
Great. Interesting point, Jenny. Okay, Ira Anderson, he asks, given that potential future low elevation climates in the Columbia Basin will likely favor development of grassland ecosystems, what are your thoughts on possible policy directions which could favor the development of these open ecosystems, similar to those prior to fire suppression?
Yeah, I think that the work that's being done by the Trench Society of reintroducing fire, thinning stands, those are by far the best policy we can be doing, but we need to be doing it in a much broader area. As you can see, these grassland steppe environments are going to extend across. The map I had didn't include the boundary region, but that one under the hot, dry one, basically the whole boundary region becomes grassland steppe environment. I think these interface fire treatments being extended across the landscape, and that, there's a paper on my website, which I produced with some assistance from Kolesnikov last summer, that looked at what we can do to treat these fire-prone forests and extend that and make them more resilient. I mean, we want to keep trees on the landscape as long as possible. But the other problem, of course, is invasive species. My worst fear is that all those areas that are red on the map will become knapweed fields, not grasslands. So we need to seriously consider that. The other thing is that the kind of grasslands that are recognized by the model are not grasslands that exist in BC. They're grasslands that exist in South Dakota, Wyoming, Arizona, Utah. So we may not have the species that are suited for the future. So we need to think about that as well.
Okay, great. Just some follow-up questions or comments, I guess, rather. Jenny just notes that the deadline for that process that's underway is November 30th, FYI. So short timeline there.
It won't happen then.
Yeah, okay. Maybe somebody can support with that. Doug Beckett asks a question, and a number of people look like they have related questions to that. It says, would you mind going back to slide 26 and explain how forests sequestered CO2 prior to 2002?
Okay. Oh, sorry. Okay, I presume it's that one. Basically, the way they sequestered carbon was by growing. Think about the huge area of lodgepole pine stands in the center of the province that were wiped out by the mountain pine beetle. Those were generally mature stands, not old growth stands. They were still growing. They were still putting on wood. And every centimeter in diameter they grow is carbon sequestered out of the atmosphere. So once those trees were killed, that sequestration stopped for a short period. Then it began to pick up slowly again with with herbs and shrubs coming back and eventually small trees. But it'll take 100 years for them to recover to the sequestering state that they were in before the mountain pine beetle. And as you can see, they haven't recovered yet. Which is why the green bars at the bottom there get shorter and shorter after the beginning of the mountain pine beetle infestation.
Okay, I'm just going to jump to a question from Marcy because I think it's related. Follow-up question about forests. Based on what you said about the importance of tropical forests and sequestering CO2, are BC's coastal and inland temperate rainforests the best forest types for sequestration? And if your scenarios show an increase in coastal species in upper elevation, what should be I think she's meant to say, should we protect these elevations so shifts can happen?
First of all, yeah, definitely the BC's coastal rainforests are extremely important and highly productive and have the largest capacity for sequestering carbon in BC. There's no question about that. And certainly the wetter parts of the interior rainforest as well. Some of the drier fringe ones are, they certainly sequester carbon, but not nearly to the extent of the other ones. It's these highly productive sites are the ones that are going to sequester the most carbon. And that's why I think that work by Price, Doust, and Holt, which looked at the state of our old growth forests on the more productive sites, the fact that they're almost all at high risk, indicates that we're not doing a good job of managing those. We've cut them down. It's basically how well they sequester forests comes down to what is the productivity of the site. The more productive the site, the more carbon it can tie up. In terms of coastal species at the upper elevations, fortunately, the dominant tree species in the coastal forests in British Columbia are the same as the ones that are in the inland temperate rainforest in most cases. So therefore, we've already got the species here. It's whether they've got the genotypes to survive in that new climate. I think that if you look at the center of the existing interior rainforest, I think that the genotypes are probably that much different. We even get mountain hemlock occurring in the wetter ESSFs in the Revelstoke mica area, indicating that they are very similar to the coastal forests. So I think it's just a matter of protecting that range of genetic diversity and keeping those old forests in particular, because they're that reservoir of genetic material that is in some cases 1,000 years old. It's basically getting back to the importance of protecting those old growth forests. I mean, it was always important from a habitat point of view, but now from a climate point of view, I think it's important from a building resilience in our ecosystems as well.
Great, thanks, Greg. I think next question, go ahead.
I just wanted to say one more thing. I think you also have to be careful in saying that those high elevations are going to be those forests. I think what those maps show is what the climate is capable of supporting it. Unfortunately, most of those high elevations are rock and have very young soils. So the amount of area that actually is going to produce a productive forest is much smaller than what the map would indicate.
Okay. So again, kind of related, this comes from Tanya Smith. How can we help our BC forests become sinks again and increase resilience in the face of potential 3 climate scenarios presented?
That's a big question.
Mm-hmm.
It really varies depending on what is the projected trajectory for any particular area. If we're talking about the low elevations in the Kootenays, I would say thinning them out and making them resilient to fire, which means being very selective in terms of what species. We've got ponderosa pine, Douglas fir, and western larch, which are all fire resistant and capable of maintaining themselves in a fire environment. So we need to be either keeping those on sites or planting them where necessary. At the upper elevations in the ESSF, it's really difficult what to say because we don't know which trajectory is going to end up. The work that a group of us did 10 years ago, we did some discussions around that. I think that for the upper elevations, because of the potential for a complete regime change, we're going to have to look at trying a whole bunch of things and then intensify our monitoring so that we see what works and doesn't work. I don't think there is a simple answer. But I think, maintaining old growth and genetic diversity is certainly a first start. We need to start thinking about which areas we want to protect from fire and can we protect them. Right now, we're putting all of our fire protection in protecting people. We're not putting it into protecting ecosystems and genetic material. Yeah, I don't it's probably not a very satisfactory answer, but it's a big question.
Okay, similarly large question that I missed earlier from Randy. What should our priorities be for changing our resource management practices for the Kootenays?
Getting away from maximizing the AAC and start looking at maximizing ecosystem resilience in the big picture answer. We need to, a lot of the conservation steps that need to be taken are not rocket science. It's basically, if you look back at the biodiversity guidebook that came in the late 1990s, there's a whole bunch of recommendations in there that we've never fully implemented. Implementing those would be a major first step. Stop thinking about the fact that we're going to maximize wood production. In the coming decades, we're going to be salvaging insect and disease and fire. We're not going to be maximizing wood production as the industry is still looking at, and our government as well. I mean, right now, the timber supply reviews don't even take climate change into account. And as those maps show, we're going to lose a lot of forest area, and that's not being considered.
Okay, thanks, Greg. Well, we have one request for you to run for Prime Minister.
Thanks. No thanks.
Okay, darn. Okay, we'll move on to the next question then. Coming from Dana, have you looked at carbon sequestration in different ecosystems like native prairie soils and wetlands, coastal marshes, peatlands, mangrove forests, North Atlantic right whales? I'm not sure exactly what her question is here, but she concludes by saying conservation and reclamation.
I haven't personally looked at that. We've been mainly looking at conservation and land management from an ecosystem resilience point of view, but there is a lot of literature out there on all those subjects that she lists. There are people looking into those things. Absolutely. I guess I have some of that literature, but it's easily available. I think that one thing I might say is, as much as sequestration is extremely important, on the other hand, it's not going to solve the problem. You're never going to sequester the amount of carbon dioxide and other greenhouse gases that we're putting in the atmosphere. Sequestration is part of the answer, but stopping our greenhouse gas emissions is the real answer.
Okay, I'm going to move on to a question from Carrie. I've heard that the BC Silviculture Forestry Program is already replanting species that are projected to be best survivors at certain elevations and ecosystems. Do you know what BC Forestry is doing in preparation for climate change currently?
That's correct. They are looking at seed transfer based on climate change, as well as then planting species that are more favorable under future drier climate, warmer in some cases. But again, it's really left to the companies to make that decision. And some of them are more aware and more careful, and other ones I've worked with here in the West Kootenays don't even believe in climate change, I don't think. I would say forestry is doing some things, but on a scale of 1 to 10, they're probably at 2. I mean, this report that I was involved in 10 years ago has never been actually fully distributed among the Forest Service. Most people aren't even aware that it was done, and there are no specific directives for people to deal with climate change. They're very vague and, in my opinion, completely inadequate. As per example, when you look at those areas that are projected to go to grassland environments in the coming decades, some of those are being logged today in the West Kootenays, and I've been part of a discussion with the district manager over we should be treating those as if they're going to become grasslands, and the answer is no, that's not policy. So although they're doing some things, I mean, the other thing the government is doing is trying to argue that their management by keeping trees on the landscape is sequestering carbon, and therefore we don't need to reduce emissions. They're arguing that they're going to improve forestry and reduce our need to reduce emissions. And I've actually talked to some of the scientists involved in that program, and off the record, they'll say, oh yeah, this is not going to happen. It's bullshit. But on the record, government is still pushing it as a way to not have to reduce emissions. I don't know. I don't think that government is taking it seriously. I mean, we wouldn't be building LNG plants if we were.
Fair enough. Okay, we are running low on time, so I think maybe we'll just sort of make one more. Okay, I'm gonna add Jenny's comment here as the last question, I think, and then we have a couple other closing comments. So Jenny says, could you elaborate on your comments on the BC government's response to the Old Growth Strategic Review report?
Okay, the report itself I thought was pretty good. In fact, I would say I was surprised by how good it was. It did a good job of talking about how we got to the old growth crisis and what needs to be done about it. The government's response, well, first of all, one of the main recommendations, the report identifies some key areas where we're really at high risk of losing old growth. And a lot of that comes out of the report by Price and Holt et al. But the government didn't respond to that at all. They could have easily just said, we're not going to log any more old growth in those ecosystems that are at high risk. They didn't even mention it. What they did do was announce 350,000 hectares of area that they were supposedly protecting old growth on. Well, most of those areas were already protected for other reasons. In fact, the two that I'm most familiar with here in the Kootenays, I worked with WildSite and Tembec and negotiated the protection of those areas 10 years ago. And now the government's saying we're doing this to protect old growth? That's ridiculous. And most of the areas that were in there are already off limits to logging for other reasons. So what they did was basically do a smoke and mirrors thing to say we're doing something and it looks really impressive, but in reality, we're not going to do it. I found it to be extremely disingenuous. There's a really good summary of that in with details about each of the areas in a publication in Victoria, which unfortunately I can't remember the name of at the moment. I think it's called Viewpoint or something like that.
Okay. There's more questions coming in, so I'm gonna squeeze them in. This one I'll add in because I know you're involved in the Columbia River Treaty committees and negotiations. So Randy asks, our watersheds are heavily dependent on the health of our glaciers. Is there anything we can do to prepare for the loss of the glaciers and how to approach the new Columbia River Treaty?
I think, well, again, in terms of glaciers, yes, glaciers are disappearing rapidly. There's no question about that. Although there was a report that came out today actually that stated that there's maybe more ice in some of the glaciers than we had previously thought because they're thicker than we thought. But that report went on to say they're still going to disappear regardless. They just might be around a little bit longer. In the Columbia Basin, almost all the glaciers that have any significance are in the far northern part, around the Canoe and the northern part of the Mica. In terms of, they're going to change and reduce the amount of flow in the fall. But in terms of actual impacts on people, it may have some minor impacts on electrical production, but because we have so many dams in the Columbia system, the likelihood of them having any significant impacts is not that great. They can be compensated for by the way we manage our dams. And where they're going to have impacts is where we've got cold water fish species that depend on that cold water in the fall and depend on cold water period. There's also going to be a tremendous change in stream flow in these rivers, where in some cases the glacial outflow is 50–60% of the flow in August and September. Those kinds of impacts are going to be great, but in a broad thing in the whole Columbia River Treaty, probably not that significant. The more important significance is actually in the southern part of the Columbia Basin in the United States, where they're switching from snow-dominated environments to rain-dominated environments, where it's not a matter of losing glaciers, it's a matter of losing snow, nature's storage. And it's bad news for electrical consumers because as the temperatures heat up, we need more electricity in the summer to run air conditioners and less in the winter to heat. And in fact, we're going to get exactly the opposite. So glaciers are a big deal, but there's other issues of climate change and effect on hydrology that may in fact be a bigger issue.
Interesting. Thanks, Greg. Okay, a comment here from Zald. I'm not sure if it's truly a question, maybe a little bit more rhetorical, but he says, is it possible to address climate change under a capitalist economic model that incentivizes the liquidation of natural resources as quickly as possible for profit?
Probably not. There's lots of papers out there discussing that. And I think that many people would argue that if we're going to stop climate change, and probably you can throw the biodiversity crisis in there at the same time, is that we need to completely change our outlook on the world. And obviously the capitalist system, which maximizes profit and externalizes costs, is a major contributing factor. That very first set of graphs that I put up are basically a result of capitalism. The assumption that never-ending growth is possible is certainly a myth of capitalism, and it's not compatible with a natural world that has limits.
Right. Okay, I think that's probably a good comment to end on. I just want to thank you very much. I know for you and for a lot of people on the line today, it's such a challenging and oftentimes really frustrating topic that requires an entire remaking of everything that we knew to solve, really. But I appreciate you sharing your knowledge with us. I wonder, Greg, if you could just go to the last slide so I could do some thank yous and wrap up, that'd be great. So again, thanks everybody who's online taking your time. Feel free to connect with us if you want to follow up with more questions. And I just want to, of course, thank our sponsor, the Columbia Basin Trust. I'm just going to bring my script over here. And again, thanks to anybody who had a chance to donate to our Crud Talk series. If you haven't had a chance to donate and you're inclined to do so, of course, you can do that on our website. There's a little donate button on the top right, and we really appreciate that. That makes a huge difference. Next up isn't until the new year, but we'll be welcoming Dr. Robin Irvine with Poisson Consulting, and she'll be delivering a talk titled, "What Can We See from Long-Term Data on the Columbia River? Patterns of Change Through Rainbow Trout Lens." So I think there's some novel information that she'll be sharing with us then. And this talk will take place on January 21st, 2021. And again, at noon. Of course, the talks are being recorded and they'll be posted on our website. I just have a small amount of editing to do and then they'll be popped up there. I don't have anything else to add, I think. I don't know, Greg, if you wanted to conclude with anything before we go.
No, thanks a lot. As I appreciate an opportunity to talk about the things that keep me up at night.
Okay, great. And yeah, lots of thank yous in the comments, Greg, and everyone. I hope everyone has a good afternoon. We'll end here. Thanks.